Welcome to page 18 of packet number 4. On this page, we're going to take a look at proportional relationships. Our I can statement says, I can compare a graph, a table, and an equation to determine the best unit rate. When we talk about proportional relationships and unit rates, we think of a few things. For example, we know that K times X equals Y. That's the equation for a proportional relationship. Please jot that down. We also know that to find K, the constant of proportionality, we need to take Y divided by X, or examine the ratio Y over X. And lastly, on a graph, the unit rate is 1, K, written as an ordered pair. Let's take a look at the problem we've been given, and we can use some of those details that we've been given about proportional relationships. In problem number 1, we're going to compare the speed of a lion to the speed of a zebra. It states a lion can run at a speed of 53 feet per second over short distances. Let X be time and Y be distance. Well, we know our K value. Please jot this down. You should be recording all of these notes. We know our K value is Y over X. And they've told us that it's distance, and we're going to be using feet for distance. And for time, X, we're going to be using seconds. And it states it right in the rate we've been given. Feet per second. So we know 53 feet per 1 second. This is our unit rate, and if we divide and get rid of the units, our K value is simply 53. So the equation for the lion using this format is 53 times every second equals Y, the distance in feet. That was pretty easy. But for the zebra, the information's been presented in a graph. Let's take a closer look. We see seconds represents the information on the x-axis, and on the y-axis for the zebra, we have the distance in feet. Whenever you are presented with a graph, quickly sketch a small t-table next to that graph. We know X represents seconds and Y represents feet. Now, it's our job to come up with the unit rate for the zebra. So we're going to grab a few readable points off the line we've been given. We know for 1 second the zebra can travel 59 feet. And for 2 seconds, the zebra can travel 118 feet. And that's all we need to write a unit rate. Well, we know K equals Y over X, which is going to be 59 over 1. And we can label that 59 feet per 1 second. And if we divide and get rid of all the units, we see that the K rate is 59. But let's think about what we have here. That means the zebra can cover 59 feet per 1 second. Pause the video if you need a little time to take down these notes. But the equation we would write is 59 times every second x equals y, the distance the zebra covers. If we compare the lion's unit rate or speed to the zebra's unit rate or speed, we can see clearly that the zebra moves at a quicker rate. Go ahead and take a look at problem number 2 when you're ready. Pause this video right now and copy down the notes if you haven't had a chance. Now let's look at problem 2 after you're done pausing the video. In problem number 2, we are comparing the speed of a rabbit to the speed of a grizzly bear. It states the distance y in miles covered by a rabbit in x hours is represented by the equation y equals 35 times x. We can see that our k is 35. So we're going to write, and you should copy down these notes, k equals y over x. Clearly, y is miles, and x is defined as hours. So we already know our k rate is 35 miles per 1 hour. And if we divide and get rid of the units, we're back to 35. But for the grizzly bear, we need to come up with a unit rate here using a t-table. We know when we're given a graph, we're going to set up a t-table. Now our x across the bottom is still hours. 1 hour, 2 hours, 3 hours, 4 hours. And going up the side, that's our distance in miles. We're going to pull 2 good readable points off this sheet. 1 hour, 30 miles. 2 hours, 60 miles. When you're ready, calculate the k rate, your y over x. Let's take 30 miles per 1 hour, which gives us a k rate of 30. Now it's time to compare who moves at a faster rate in an hour, a grizzly at 30 miles per hour or a rabbit at 35 miles per hour. Write an equation for each and complete this sheet. This concludes page 18.